Let's look at a few examples. What is the weight of 1 kilogram of iron? The weight is the mass times the acceleration. The mass is 1 kilogram. The acceleration is 9.8 meter per second squared. 9.8 kilogram meter per second squared is 9.8 newtons. How much work is done raising 4 kilogram mass to the height of 16 meters above the ground? The work is the 4 times the distance, and the mass is constant throughout. So the work is 4 kilogram times 9.8 meter per second squared times 16 meters, and this is 627.2 kilogram meter per second squared times meter. It is 627.2 newtons meter, or 627.2 joules. How much work is done raising 4 pounds to the height of 16 feet? Now, 4 pounds is already the unit of force, so the work is 4 pounds times 16 feet, which is 64 foot-pound. Note that the weight pounds is already the unit of force. A 45-meter rope with a mass of 30 kilograms is needed to be pulled up. The work is the force times the distance, 30 times 9.8. So what's wrong with this solution? The force required to pull the entire rope is not the same as the force used to pull a part of the rope. And so the force used varies depending on how much left. The force used initially to pull the entire rope is greater than the force used to pull part of the rope. And so in this case, since the force is not constant, we cannot find the work by using the product of force and displacement. Notice that the displacement is not constant because the remaining part of the ropes are not the same. There are two ways to look at this. Initially, when the rope is 45 meters long, the force needed to pull the rope up is much greater than, say, when the rope still only has 5 meters left. Or we can think of it that we were to move one segment of the rope at a time. Initially, the bottom part of the rope needs to travel a distance of 45 meters, but as we pull the rope up, at that point, when there are still 15 meters left, for example, then the bottom of the rope needs to travel a distance of 15 meters only. And so in this case, the distance is not constant.